Hi guys, on this video, we are going to discuss a few concepts about the normal distribution, which is going to be, I think, your last module. Okay, so just remember that a normal distribution is a symmetric figure, and is also called the normal curve or bell curve. Now, it is symmetric because they call it normal distribution, because the mean, the median, and the mode are equal or very, 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 very close each other. So the mean, the median, and the mode is going to be in the middle. We use the standard deviation, which is named by the Greek symbol sigma, to describe the variation of the data around the mean. You are going to find a copy of this standard deviation graph in an announcement, and it's going to be very handy to understand how to use this. If you are going to take statistics, you're going to study this in more detail. But for this class, we are just going to stay with just using this graph. So the empirical rule 68, 95, 99.7, what that means is that where the values are going to be in there in here in the normal curve. So we're going to start from the center outside. If you notice here, here is mu, which means the mean. This is the mean here. And we start adding one standard deviation from the mean to the right side, or subtracting one standard deviation from the left side of the mean, and then add or subtract two standard deviation, add or subtract three standard deviation. So the empirical rule says that the data between the minus one standard deviation and positive one standard deviation from the mean represents 68% of the data. If we go from two standard deviation from the mean of each side, that represents 95% of the data. And if we go to three standard deviation of each side of the mean, that represents 99.7% of the data. If you add that, it's not going to be a whole 100%, because this part here is very close to the line, but we have some data here that we complete on both sides that is going to complete 100% of the data. But between the three standard deviation of each side, we have 99.7. So the rest of the 0.3% represents those tails after that. So again, we are going to use this diagram to solve some problems with the empirical rule. It's very important that you noticed that this is divided into sections. So you have to understand that this section here represent 0.15% of the data. This section to the to here represent 2.35% of the data. That this section represent 13.5, this section represent 34, and so on. Okay, so that's that you have to see this diagram. So it says the score on a standardized test were normally distributed with a mean of 510 and a standard deviation of 95. Use the empirical rule to complete the following statements. Okay, the first thing that I suggest to do is rewrite this part here, but with the numbers that you have on the problem. So I'm going to make a line, and I'm going to divide it in 7 sections, 5, 6, 7, and the middle is the mean. See here, that is the mean, and the mean is 510. That's what I'm going to write there. Then to the right side, it says that the standard deviation is 95. So I'm going to add 510 plus 95, and that is going to give me 605. And then to that number, I add again 95, and that gives me 700. And the last one, I add 95, and that gives me 795. Now to the left side, I'm going to subtract 95. So I start with 510 minus 95. That gives me 415. 415 minus 95, that gives me 320. And 320 minus 95, that gives me 225. Now I can answer my question. If you want to make the curve, you don't have to, but if you want to, you just can do something like this. Okay, better than mine, hopefully. Okay, so the first question is, 68% of students taking this exam score between. So when you look at this chart, which you're going to have in the exam, so you don't have to worry about it. Here it says that 34% plus 34%, this represents 68% of the score. So that means that the answer is that the score between 415 and 605 represents 68% of the score. Now to figure out the 95% of the score, well, 95%, it would be 2 standard deviation. So it's going to be from here to here represent 95%. When I look at my chart, that would be from here to here is 95%. So that would be between 320 and 700. And then now the 99.7% would be 3 standard deviation, which is going to be here. So this part here, all of this represents the 99.7% of the score. So it's going to be between 225 and 795. So definitely having this diagram in front of you is going to help you a lot. Okay, so let's see the next one. Okay, the next one is the amount of soda dispensed into a 20-ounce bottle by an automatic dispensing machine has been identified as possessing a normal distribution with a mean of 20.5 ounces and a standard deviation of 0.2 ounces. Use the empirical rule to answer the following questions. So let's go to the next slides. So the first question is, what percent of 20 ounces bottle have between 20.3 ounces and 20.7 ounces? So the first thing I'm going to do again is to make my my normal distribution, you know, the numbers and how to do that. We know that the mean is 20.5 ounces. And, oh, I'm sorry, I'm going the wrong way. The mean is 25 ounces and the standard deviation is 0.2 ounces. So I start with the mean, which is 20.5, and add 0.2 to the right side and subtract 0.2 to the left side. Okay, so the question is, what percent of the bottles have between 0.3 and 20.3 and 20.7 ounces? So it would represent this area here. When I look my diagram, I notice that it's between here and here. So that means 68%. So the answer here would be 68%. Okay, so that would be, and this is the way to use the diagram. Okay, now the next question is, what percent is of the bottles are between 20.1 and 20.5? So what I'm doing here, I need to add the values of these two sections here. So this section here is 13.5, and this section here is 34%. So the answer would be 13.5 plus 34, which that gives me 47.5%. So that's the percent of bottles between 20.1 ounces and 20.5 ounces. And this is in real life, guys, what the companies use to calibrate the amount of liquid that they're going to put in the bottle. Not always you're going to get exactly 20 ounces of water or whatever in the bottle. Now, the next one is asking us what percent are from 20.5, which is here, and 20.9, which is here. So again, it's these two sections here. This section here is 34, and this section is 13.5. So again, in this case, it's 34 plus 13.5, which is also 47.5%. Okay, again, using the diagram will help you to figure out this better. Here's another example. So we have, the first thing I'm going to do is have my values. So 1, 2, 3, 4, 5, 6, 7. And here the mean says that the mean is 119 and the standard deviation is 22. So 119 plus 22 is 141, plus 22 is 163, plus 22 is 185. 119 minus 22 is 97, minus 22 is 75, minus 22 is 53. Okay, now I can answer my questions and with the diagram in front of me. So what percent of the electrical bills are between 75 and 119? So again, it would be from here to here. So this is going to be 13.5 plus 34, which is 47.5%. Okay, B is asking us what percent of the electrical bills, let me erase this so we don't get confused, of the electrical bills are less than 75. Okay, so less than 75 is going to be here this way. Okay, so that would be this way. So less than 75, we have this section here and we have this section here. So it's going to be 0.15 plus 2.35, and that is going to give us 2.5% of the electrical bills were less than 75. So notice how important it is to know the values that you have, you know, in this area here, and that's what this represent here. Okay, and C says what percent of electrical bills are greater than 185? So 185 is in here, and greater would be this way. So the answer here would be 0.15% of the electrical bills are greater than 185. Let's see one. Here is just, you know, telling you that greater would be this little thing that is the, here is the 0.15%. And the last one about this is asking us what percent of electrical car bills are greater than 97. So 97 is here. So greater than 97 would be all of these. So I'm going to add 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Be careful because most of the students missed the last little tail, the 0.15. And when we add that, the answer is going to be 84%. So this is all we have to know about the normal distribution and how to answer those questions. The last part of this module is about the standard scores, which is called the z-score. And the z-score measures the number of standard deviation that a specific value in the data it is from the mean. If the answer, the z-score, is equal to 0, that means that that value represents the mean of the distribution. If the z is positive, then that means that that value is above the mean. And if the z is negative, that means that the data is below the mean. And we are going to use this formula to find out the standard score or z-score, and you're going to have it on the test also. So what you have to remember is that x represents the data value, mu represents the mean, and sigma represents the standard deviation. So we have this example. It says scores on a standardized test are normally distributed with a mean of 510 and a standard deviation of 95. A student scored 365 on the test. What is the standardized score? Meaning, what is z? Well, the value of the test was 365, and that represents x. The mean is 510, which is mu, so it would be 365 minus 510. And the standard deviation is 95, which is sigma. And when you solve this in your calculator, it's going to give you approximately negative 1.53, round to 2 numbers after the decimal point. So what is the meaning of that? This is the way to see this. On the left side graph, it is where the z-score will be, having all your numbers representing z, and on the right side is just telling you where the 365, which is the score of the student, will be. So notice that because the standard, the z-score is negative, is below the mean. But what you have to know is how to use the formula to find the z-score. Now, in this case, we have to solve for x because it's telling us that the z-score is 2.2, that the mean is 510, and the standard deviation is 95. So when you write it in the formula, we have to find x. So our first step is going to be to multiply both sides by 95 here. So we can cancel this with this. And we are going to have then that 95 times 2.2, that is 209. So then you're going to have 209 equal to x minus 510. Now to solve for x, we are going to add 510, and the final answer is going to be 719. So 719 will be the test score that will represent a z value of 2.2 with a mean of 510 and a standard deviation of 95. And here just showing you again what it's going to be. And again, because the z-score is positive, notice that is above the mean. Okay, another example. We have a z-score. What is the z-score for an A, which is 93% on the test, which has a mean score of 82 and a standard deviation of 7. What is percent? You just treat it like a regular number. So z is going to be 93 minus 82 divided by 7. And this is going to be 11.7, so approximately it's going to give you 1.58. Okay. Here, the college entrance exam, the mean was 70 and the standard deviation 8, and a student score was, as this score was negative 1.5, what was the exam score? So I have negative 1.5, which is Z. I'm looking for the score, which is X. The mean is 70, and the standard deviation is 8. I'm going to multiply both sides by 8 here to cancel this 8 from here. And that is going to give me negative 12 here equal X minus 70. And now I have negative 12 plus 70 equal to X. So the score 70 minus 12 is going to be, X is going to be 58. And that's the value of the test with a z-score of negative 1.5. And how you know that your score, your answer is correct? Well, my z-score is negative, and the mean is 70, has to be less than 70, because when z-score is negative, is below the mean. Okay, here's the last example. We have here that the mean is 62 pounds and the standard deviation is 6. We need to find the z-score when the dog weighs 55 pounds and the standard deviation is 62, the standard deviation, the mean, and then the standard deviation is 6. So when you solve that, it's going to give you negative 7.6, which is approximately negative 1.17. On the other one, we need to figure out X, because it's giving us the standard, the S score, which is negative 3.2, X minus the mean is 62, and the standard deviation is 6. I multiply both sides by 6 to eliminate this, and that gives me negative 19.2 equal X minus 62. So X is negative 19.2 plus 62, and that is going to give me 42.8 pounds. And that's what you have to do in this part with the z-score formula. On the exam, read carefully, because they might mix different information. They can say, for example, the weight of a certain male dog breed is 62 pounds and the female is 50 pounds. And you have to be careful to see which one is asking you, if from the male or the female. So this is everything that I have about the last module. Hopefully this is going to help you with the assignments and the exam.